Hello dear students. Today I will start chapter 6. Okay, new chapter, study of first element, hydrogen. Students, that is my note from my copy. So elaborately it has given over here, because in higher class also you have to learn this chapter. In class 11 also that is present. So um, the basic things what in your class is present, that I will explain. But basically in these chapters you need to memorize. Okay, you need to memorize, you need to learn, and those need a explanation. I will explain. First thing, hydrogen is the lightest element and also lightest gas in the periodic table. Students, generally these from these portions, 1 mark question can come in your exam. So if you learn, it will be good for your memory, means your knowledge, and for the exam as well, for 1 mark question. So hydrogen is the lightest element and also the lightest gas in the periodic table. It is most abundant element in the universe. Okay, in the universe, not in the earth. Earth and universe is different. Here I have written, you can see, most abundant element in the universe, hydrogen. Then second is helium, third is oxygen. These types of question used to come, that which is most abundant element in the universe. Secondly, student, if most abundant element in the earth the question will come, then that is oxygen. Okay, 46.6%, and which is a non-metal. And second is aluminium. Okay, so in earth that is oxygen, aluminium, and third is iron. And so aluminium, oxygen is non-metal and aluminium is the metal. So most highly abundant metal in the earth is that is aluminium. Okay, so that simple things you need to know. Okay. And in our human body also, you can remember that most abundant element in our human body, that is oxygen. Okay, then carbon. Okay, 65% of the human body is the oxygen. In atmosphere, that is nitrogen. Okay, 78% nitrogen is present in atmosphere. Okay, so student, that is all about a little bit concept has given. And 70% of the total mass of the universe contained by hydrogen. It is lightest non-metal. It is, so hydrogen is a non-metal, must remember this thing. It has given, keep in the periodic table. I am showing your book also here, on the series, on the group of metal, but still it is a non-metal. Okay, so hydrogen is a non-metal which keep on the same column, same group of metal. So students, here it is lightest non-metal. It is simplest element in the periodic table, because student, it doesn't have any neutron. Okay, it has only one proton and one electron. Okay, so that's why its mass also 1 amu. Okay, there is no mass of neutron. That's why the mass of a hydrogen is the equal to mass of a proton. Okay, that's why H plus is called as a proton, because H plus means hydrogen release one electron. So as hydrogen or generally contain one electron, one proton, so one electron release means it has only one proton. That's why H plus is known as a proton. And generally in nature, H plus doesn't exist. In experimental lab also, hydrogen ion, because it is very small, too small. So we will get it as a hydrolyzed form, means H plus react with H2O, form H3O plus, hydronium ion. Okay, so hydro combine with hydrogen, combine with water. H plus combine with water form hydronium ion. That's why we test with by using that hydronium ion, not hydrogen, because hydrogen is not experimentally, it not exist. Okay, because it's and its structure is, it's very small, very very extremely small. So that is the thing, student. Basic knowledge. Discovery, it's discovered by Henry Cavendish. Okay, and was called inflammable element because it can burn in presence of air. Okay, it has different isotope that is not present in your syllabus, but for basic knowledge. So I am doing little bit reading from your book. Okay, it will be better to understand. Students, that is to here symbol molecular formula H2, because it is diatomic, valency is 1, electronic configuration 1, and that electron present in the K cell. and position in periodic table, 1a group first period. That is position of hydrogen in the periodic table. There is a big confusion because you see here hydrogen is the first element in the periodic table. Its atomic number 1, and it has only one electron in its valence shell, therefore it belongs to first group and first period of the periodic table. It is expected that properties of hydrogen should be similar to those other member of the first group. Other member means lithium, sodium, potassium. Okay, but student, this is not this is not the case. Ever since Mendeleev presented his periodic table, the position of hydrogen has been a matter of controversy and debate. Okay, because student, the main problem is that hydrogen resembles the property of group 1 element, means alkali metal. First group is called alkali metal, whereas the other are similar to those group 17, means halogens. Okay, so hydrogen has the properties which is similar to the first group, okay, alkali metals, whereas the halogen. So this first group and halogen, so there is a big controversy where you will place the hydrogen from the Mendeleev's time. So Thomson suggests a separate position for hydrogen. He puts it at the top of periodic table that does not disturb the symmetry of the periodic table. Okay, symmetry of the modern periodic table. So here after that you can see that hydrogen shows a dual nature since it resembles the alkali metals of group 1a and halogens of group 7a. Means group 1 and group 17 both elements characteristics has shown by the hydrogen. So where we will kept a position, separate positions, single position had given by the Thomson to not to disturb the periodic table, that is above the group 1, and there is the position of hydrogen, but still there is a controversy. So what are the similarities? That is from your book you can learn, students. And here I am showing my copy. Here you can see a tabular form I have mentioned. Okay, that first point you can see that electronic configuration of alkali metals and halogens. Okay, what are the similarities? Similarity, first we will learn the similarities, then differences. So similarities, alkali metal, suppose sodium, 281, so last electron go ns1. Similarly for hydrogen also, its electron is 1, so 1s1 or ns1. So students, last electron, like outermost electronic configuration is same. Okay, outermost electronic configuration is same, just like other elements on the same group. Similarly student, for halogen, suppose chlorine. Okay, chlorine, 287, suppose fluorine 27, so it accept one electron and form 28. Okay, so it will accept one electron to gain noble gas configuration nearest. Similarly hydrogen 1 will accept one electron to make 1s2, means gain the electronic configuration like helium. Okay, so that is a similarity for like halogen gas. So where you will keep like fluorine, hydrogen also wants to take the nearest noble gas configuration. Second, you can say both form unipositive cation. Sodium, potassium, rubidium, whatever the group. If I mention one, you just remember other also. All these lithium, sodium, potassium, they will form +1 unipositive ion. Similarly, hydrogen also form +1. Hydrogen will form. Similarly, student, both form uninegative ion. Fluorine will form take one electron to form F minus, because always they will take one electron to gain noble gas configuration. Similarly student, hydrogen can take one electron to form H minus, that is hydride. So so I think you are enjoying. So where you will place it? So hydrogen also form H minus, like one compound sodium hydride, NaH, a compound found in, you can found, that is sodium hydride, where sodium is Na plus, hydrogen minus. So lots of hydride compound is there. So there is a similarity. Similarly student, both are for the same type of oxides. What is the oxides of sodium? Na2O. Similarly oxides of hydrogen is H2O. So similar oxide. Okay, similar halides. Okay, halide sodium NaCl, similarly HCl. Okay, sodium halides means react with halogen to form similar halide, sodium chloride, potassium chloride, similarly hydrogen chloride. Okay, similar sulfides. So characteristics is same. Similarly, student, for in case of halogens, similar hydride they will form. Suppose chlorine react with um, sodium, means sodium chloride, sodium hydride, that so you have learned. So when electrolysis happens, sodium chloride, electricity will pass, they will form sodium ion and chlorine gas at anode, in cathode anode. So that in senior class you will learn what is electrolysis. So in cathode, sodium metal will deposit, and anode a chlorine gas. Similarly, sodium hydride will show electrolysis form sodium at cathode and hydrogen gas at anode. So that is the similar property. Here also point 4, sodium chloride, hydrogen, that these are not present in your book, student. Only whatever is present, reducing power is present. Okay, both are act as reducing agent. Okay, copper oxide, hydrogen reduced copper oxide to copper. Similarly, sodium reduced copper oxide to copper. So both are reducing agent that is present in your book. So you can remember this. Okay, that ionization is not present, but you can still you can read it. Okay, and alkali metals, they react with alkali metals to form sodium halide. Similarly, sodium also, hydrogen also do the same type of reaction. Okay, I hope you understand from here, and then you read your book. A basic concept you will get, no problem. Now, students, what are the differences? Hydrogen atom has only one cell, but alkali metal doesn't have. Here, from your book, you can see the differences. Hydrogen atom has only one cell, but alkali metal and halogen have two or more cell. Because you know that fluorine is 2,7, means for fluorine at least two cell is present, 1 and 2, 2 and 7. But hydrogen has only one cell. Okay, alkali metals also, another alkali metal sodium, at least lithium, lithium 2 and 1. So all that is the differences, means hydrogen is does not matching with either one or either halogen. Okay, because halogen and halogens, these are halogens, fluorine suppose, halogens, and or these are alkali metals, all have more than two or more than two cell, but hydrogen has one cell. Similarly, another difference is that oxide of hydrogen H2 is a neutral oxide. Water is neutral, we drink it. Okay, so it is neither basic neither acidic, it is neutral. Okay, that's why it's tasteless water, you can say. Okay, it is tasteless. Similarly, other oxide of halogen are acidic and oxide of alkali metals are basic. I told you, students, oxides of metals are always basic in nature, and non-metal oxides are acidic, because non-metal oxide dissolve in water to form their respected acids. Now, students, come to the so that is complete lecture for today. Next class I will talk about the discovery and occurrence from your book.